Good morning everyone. Last time we have discussed about the colloids and their classification. Then we have said that there are two different type of colloids on the basis of the interaction of the solute and solvent, that is dispersive medium and dispersion phase. So on that basis the type of colloids were the lyophilic colloids and the lyophobic colloids. I have also said that the preparation of lyophilic colloid is very easy process. That means you can easily prepare the lyophilic colloid just by adding the phase in warm medium. When the medium will be just warm, that will dissolve the dispersive phase within it and the colloidal system will be prepared. But when you will see the lyophobic salt, what are the conditions for the lyophobic salt? When you will see the lyophobic salt, that cannot be prepared as easily as that of the lyophilic salts. Then how will you prepare the lyophobic salt? For example, we have last time discussed that how we will prepare the gold salt. Surely you know well that the gold is undissolvable with water. That cannot be dissolved with water, and if gold cannot be dissolved in water, then in that condition it is very difficult to dissolve gold in water without any specific technique. Then what are the methods for the preparation of these of the lyophobic colloids we are going to study here. The first method whatever we are going to study, that is the chemical method. When we talk about the chemical method, we treat any of the substance and convert it in the compound which is soluble in water. For example, if you are taking iron and if you are trying to dissolve iron in water, what happens? Whether iron will be dissolved in water? Surely not. You have seen it. आपके कॉलोनी में इतनी सारी व्हीकल्स पड़ी रहती हैं, बारिश होता है, कभी आपने नहीं देखा कि बारिश में 2-4 गाड़ियाँ डिजॉल्व होके बह गई. That means iron is undissolvable in water. But what's about the salt of iron? Salts are dissolvable. So if we are capable to convert the salt in the convert the metal in the form of the salt, then that will be dissolvable and we are easily capable to find the salt by removing the counterions. So if you are taking iron, surely that is undissolvable. But if you are taking acid with it, it will form ferric chloride FeCl3 along with hydrogen. This ferric chloride is easily dissolvable in water. So when this ferric chloride FeCl3 will dissolve in water, it will form FeOH thrice, which will be called iron salt. In this way, any of the metal or those of the substances which are undissolvable in water can be converted in the form of the dissolvable salt and that can be dissolved in water. The problem with this method, the counter ions are available. When you will see this one, along with the iron salt, there is HCl. I have not written the byproduct, but when you will see the byproduct, it will be HCl, which is not needed, and even the excess of electrolyte can coagulate the colloid, can destroy the colloid, can suspend the colloid. So the excess of electrolyte is also not good for the colloid, and this is the main problem with the chemical process, that along with the main product some of the byproducts are also formed, some of the byproducts are also dissolved in the colloid, and as a result the stability of colloid may lost. So we need a technique, we need a method for the removal of those of the materials which are not needed in the colloid. But this is one of the best method for the preparation of any of the colloid. The phase may be metallic, may be non-metallic. You can prepare the salt of the iron, you can prepare the salt of the gold, you can also prepare the salt of the sulfur, which is a non-metal. So you can prepare the metal as well as non-metal salt with the help of this method. Then this is the one of the best method for the preparation of the salt. This is the chemical method. Another profit with this method, the loss, the physical loss of the material is almost negligible. So if you are making any of the salt which is very precious, that can also be prepared by this process. Some other process which is given in your syllabus is generally physical process, and the one is the Bradycard method. In this Bradycard method, we take such container. There are two containers, one within another one, and it is filled with ice. That means we are trying to generate a ice bath. In this ice bath, we have taken the medium. I am just writing medium, it is the dispersion medium. We have taken the dispersion medium in which you need to prepare the colloid. Now, we will add the phase in the form of the electrodes. Now, these two electrodes are there. That means only those of the materials which are conductor of electricity can form the colloid with the Bradycard method. So, this method is useful only for the non-precious metals. Why metals? We have already discussed. Why non-precious? Because the process is physical process, and the efficiency of physical process is very low with respect to that of the chemical process. So, in the case of the chemical process, we can use the precious as well as non-precious materials, but generally in the case of the physical process, because of the extra loss of the material, because of the heavy loss of the material, we generally use only those of the materials which are non-precious by the nature. So, generally we are not going to use any of the material which is precious, which comes in the category of the precious materials, precious metals. So, we are going to prepare the colloid only with the help of the metals, and only those of the metals which are not considered as a precious metal. Now, what will be the next step? Now, after this such arrangement, this is the ice for the generation of ice bath, the medium, and these are the electrodes are surviving as a phase. Now, what will happen? We will generate a short circuit. And in the process, when the circuit will short, the heavy electricity will turn in the form of the heat. That is called the heating effect of electricity. The heating effect of electricity will melt the metal, and this molten metal will dissolve in this liquid, and in this way the formation of colloid will take place. The process is very low efficient. Only less than 10% material dissolve in water. In the process, when such a heavy heat is evolving that is capable to melt the metal, then whether it will not boil the liquid, whether it will not evaporate the liquid, surely that will evaporate the liquid. But for maintaining that temperature, we are using the ice bath. As a result, the material may retain in the container and the colloid system may form. And this is one of the best method which is considered as a physical method, one of the best physical method for the preparation of the colloid given by Mr. Brady, and so it is called the Bradycard method. I think it's clear to all of you. This is only for the non-precious metals. Non-metals cannot be prepared by this process because non-metals cannot conduct electricity. And as it is a physical process, there is a heavy loss of the material. So, we say that this method can be used only for those of the metals which are non-precious, because in the preparation of the precious metal colloids, we will lose the heavier amount of the material, and that will not be economical for the person. The next method for the preparation of colloid is peptidation, which is actually not a method for the preparation of colloid. This is the method for the regeneration of the freshly destructed colloid. So if any of the colloid is freshly destructed, what will you do? You will take the colloid within a container and add a peptiding agent. Peptiding agent may vary from colloid to colloid. अलग अलग colloids के लिए अलग अलग peptiding agents हम use करते हैं. Now we will add the peptiding agent, little warm condition and the styrene, and you will find that your colloid is regenerated. This method is only used for the regeneration of the colloid. No any new colloid can be prepared by the process of peptidation. So the peptidation is the process for the regeneration of colloid. The generation of colloid, the preparation of colloid cannot take place with the help of the peptidation. Now, only these three processes you will have to study in your syllabus. Now, after the preparation by these of the three processes, that is the chemical process, Bradycard process and peptidation, what happens? In the first process, there was some of the byproducts. For example, in the preparation of the iron salt, we find that the HCl was dissolved in the liquid, and that was responsible for the destruction of colloid, for the suspension of colloid, if excess of that material will take place. Similarly, in the Bradycard method, the process was a physical process, so that can ionize some of the other material. So there must be some of the impurities in the system. And in the process of peptidation, we add peptiding agent, again a impurity. So in all of these of the preparation process, there are some impurities which needs to be removal. Without removal, we knew the destruction of colloid may take place, and so we go through the different purification process. The purification process, whatever given in your syllabus, in the peptidation, in the dialysis, electrodialysis, along with the ultrafiltration. So we are going to discuss about the dialysis. What is dialysis? Dialysis is the process for the purification of the colloid, as you already knew. On what basis the dialysis runs? Surely every process has some principle. That on what principle the dialysis works? The dialysis works on the principle of diffusion. You knew about the diffusion. In the case of diffusion, there is no any need of the semi-permeable membrane. So a semi-permeable membrane is only needed in the case of the osmosis. In the case of diffusion, there is no any semi-permeable membrane is needed. So in absence of semi-permeable membrane, the diffusion takes place, and in the case of diffusion, the solute particle moves. The solute particles moves from higher concentration to the lower concentration, and this process is called diffusion, and this process is used in the process of dialysis. So I am trying to explain you the process of dialysis. Then see, this is the process for the dialysis. This is the arrangement for the process of dialysis. So when you will see, this is the system. This container is a porous container. It must be clear that it is a porous container, not a semi-permeable membrane. Through this porous container, when we will take the colloidal system within it with the electrolyte, and we are passing the water through this one. Water from the lower end to the higher end. As a result, the water will remain in your container. So when you will generate such condition, what will happen? The electrolytes are already available in your colloid, and you are taking a pure water, that is called the distilled water. In this condition, the process of diffusion will take place from the porous container, and we know that the electrolytes, that is the solutes, move from the higher concentration to the lower concentration through the process of dialysis. So the electrolytes will move outside the container, and when the electrolytes will come out from the container, the purification of colloid will take place, and this is the process of dialysis. That means the process of dialysis runs on the principle of diffusion, and this is one of the easiest and the best method for the purification of the colloid. Even this process have a little problem, that the rate of the purification of colloid in this case is very slow, because the rate of diffusion is not very quick. Even though you can see the process is very easy, that is not needing any of the cost, only the supply of water is needed. But what happens if you will continue the process of dialysis? That is called the persistent dialysis. What will be the result of the persistent dialysis? If you will continue the dialysis or you will persist the dialysis, after a period of time, you will find that the completely removal of the electrolyte will take place. Then what? We are just going for the purification of the electrolyte. We are just trying to purify the colloids. If 100% electrolyte is removed from the system, that will be the better thing. But actually that is not the condition. When 100% removal of the electrolyte will take place, the stabilization of the colloid will destroy. And the colloid will destroy. That means the suspension of the phase will take place. The destruction of colloid will take place, which is chemically called coagulation. So the persistent dialysis leads to the coagulation. So this is the process for the purification of colloid. In the next period, we will see the different process for the purification of colloid and some other topics. Till then, bye. Have a nice day. Thank you.